Moving on to example number 8. An object is launched from a platform. Its height in meters, x seconds after the launch, is modeled by the function h of x is equal to negative 5x squared plus 20x plus 60. Here we have to identify the key features and then graph the function. After that, we're going to write a sentence to describe what each indicated key feature means in the context of this scenario. So let's begin with concavity. I'm going to label all of the key values. A is negative 5, B is 20, and C is 60. Concavity is determined by the A value. Because the A value is negative, we're going to say that this is concave down. To get the y-intercept of a quadratic in standard form, we get the coordinate 0, C. And here the C value is 60, meaning that the y-intercept is going to be 0, 60. Now, to find the x-intercepts of this quadratic equation, we have to set the function equal to 0. So we have 0 equal to negative 5x squared plus 20x plus 60. Now here we could proceed by using the quadratic formula. Since we already have all of the key terms, we can just plug them into x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, because I'm not explicitly being told to solve this using the quadratic formula, I'm going to take a different approach. Here, feel free to use this if you like, or you can use this strategy that I'm going to show right now. But I realized that my trinomial, they all have a common factor of negative 5. So I'm going to divide everything by negative 5. On the left-hand side, I'm still going to get 0. But on the right-hand side, the negative 5 divided by negative 5 is going to give me 1x squared. Then 20 divided by negative 5 is going to give me a negative 4x. And then 60 divided by negative 5 is going to give me negative 12. Here I could relabel my A, my B, and my C, and I can apply a quadratic formula with these new values. But I am going to instead proceed by solving this by factoring, since my leading coefficient is 1. And then here I can find the two numbers that multiply to negative 12 but add to negative 4. So I can rewrite this trinomial as x minus 6 multiplied by x plus 2. That's equal to 0. Using the zero product property, I can set each factor equal to 0. So I get x minus 6 equal to 0 and x plus 2 equal to 0. Solving these two equations, the first one, I'm going to get that x is equal to positive 6. And then the second one, I'm going to get that x is equal to negative 2. So these are my two x-intercepts. If you would have used the quadratic formula, you would have gotten the same two results. Now I'm going to calculate the axis of symmetry. So I need to calculate negative b all over 2a. So my my b value is 20. So I'm going to get negative 20. And then I'm going to get 2 multiplied by a. My a value is negative 5. So I'm going to get negative 20 all over 2 times negative 5 is negative 10. And then negative 20 divided by negative 10 will give me a positive 2. To find the vertex, I am now going to evaluate the function at 2. So I'm going to get h of 2 equal to negative 5 multiplied by 2 squared plus 20 times 2. And we're going to add 60. Here I'm going to get negative 5 multiplied by 2 squared. That's going to be 4. We're going to add 20 times 2, which is 40. And then we're going to add 60. Negative 5 times 4 is negative 20. And then 40 and 60, I'm going to simplify these into 100. And negative 20 plus 100 is going to be 80. Together the vertex is going to be 2, 80. And now we are ready to graph. To graph this function, I've scaled the y-axis by tenths. The x-axis are still scaled by ones. So I'm going to begin by plotting the y-intercept at 0, 60. And next I'm going to plot the vertex at 280. So I'm going to go 2 and then go all the way up to 80. And my x-intercepts are at 6 and -2. So here is 6. And then -2 is going to be right here on the left. But due to the context of this story, recall that the object is beginning from a platform. So our object is starting here, so it wouldn't make sense that we should be plotting this point right here, since this trajectory is basically being ignored. So now that we have these key features, I'm going to plot, well, I'm going to graph this parabola, a sketch of the parabola. And finally, here are what each key feature represents. Moving on, example number 9, a gannet dives into the ocean to hunt for sardines. The height of the bird in feet y and the time in seconds x from the start of the dive is modeled by the function y equal to 2x squared minus 16x plus 25. After the gannet dives and catches the fish, when does the bird get out of the water? So here's the scenario. We have a gannet and it spots a fish swimming underwater. So the gannet decides to dive and catch the fish, and then it gets out of the water. So this problem is asking for the time that the gannet got out of the water. So we're going to be trying to find the x-intercept. Now, if we proceed by doing the quadratic formula, we're going to be getting 2 answers, but we're going to disregard the smaller one since the bigger one is going to represent the bird getting out of the water. Here's the quadratic formula, and I've labeled the key terms. So now let's go ahead and plug them in. So I'm going to get x equal to -b, and my b term is -16. Plus or minus the square root of b squared. So I'm going to write -16 squared. We're going to subtract 4 multiplied by a multiplied by c. A is 2 and c is 25. And we're going to divide all of this by 2a. So 2 times 2, since a is 2. Okay, this is going to simplify into, here we have negative, negative. So that makes a positive 16, plus or minus the square root of -16 squared. So that's going to be 256. And then we're going to subtract 4 multiplied by 2 is 8. And then 8 multiplied by 25 is going to be 200. And that's going to be over 2 multiplied by 2, which is 4. Okay, so here we now have 16 plus or minus the square root. And 256 minus 200 is going to give me 56. And then we still have the 4 on the denominator. The 56, I can simplify it if I get its prime factorization. So here, that's going to be 8 multiplied by 7. 7 is prime. And 8 is 4 times 2. 2 is prime. And then 4 is 2 times 2. I have the entire prime factorization. So here I'm going to get 16 plus or minus, and I can cross out a pair of 2's. That's going to mean that we're going to be able to have 1, 2 outside of the radical. These 2, I can't pair them up, so they're going to remain underneath the radical. And 2 times 7 is 14. Finally, the 16 and the 2, they share a greatest common factor of 2. So I'm going to factor out that 2. 16 divided by 2 is going to give me 8. Plus or minus, and then 2 divided by 2 is 1. So we get 1 root 14 all over 4. The 2 over 4 cancels or reduces to 1/2, and we get that the solutions are 8 plus or minus root 14 all over 2. That takes into account both solutions, but recall that we only want this one, the one on the right, so we want the bigger one. So here we have 8 plus root 14 all over 2, and then we have 8 minus root 14 over 2. So here this one's going to be bigger since we're adding, and here we're subtracting. Now, because I want the time, I'm going to approximate this, and using a calculator, I got an approximation of about 5.87 seconds. So at about 5.87 seconds, the gannet got out of the water. Let's view at another application problem using the same scenario, and this time we're going to find how deep the fish is when it's getting caught. So referring back to our diagram, we can see that the depth of the fish is exactly the vertex of the parabola. And to calculate the vertex, we're first going to calculate the axis of symmetry, which is negative b over 2a. Then we're going to plug the axis of symmetry onto the equation, and that's going to give us the y value, aka the feet, or how deep the fish is. So here, let's begin by calculating a negative b over 2a, which here the b term, if I label these terms, the b term is going to be negative 16. And we're going to divide that by 2 multiplied by a, which is 2. Now the negative is going to come to positive, and then on the denominator 2 times 2 is 4, and 16 divided by 4 is 4. So the axis of symmetry is 4. Now we're going to plug that in to find the y value here. So we're going to replace all of the x's for a 4. And now we're just going to evaluate this. So here we're going to get 2 multiplied by 16. We're going to subtract that by 16 multiplied by 4, which is 64. And then we're going to add 25. 2 times 16 is 32. And then going from left to right, 32 minus 64 is going to be 32, or negative 32. And then if we add 25, that's going to give us negative 7. Hence, the fish is 7 feet deep.